In this video I will show you what millis is and why it is super helpful to write non-blocking code. There is this function called millis. And millis is great because millis returns the milliseconds since Arduino started. Let's serial begin. I will store this millis inside of a variable. Now to store it, we need to know which type it has, because we can't just store it inside of a byte. That won't work. You can find out which type it has by moving the mouse over it, and then it reveals unsigned long. And we need to store it inside of an unsigned long variable. And then we serial.print line x. So as you can see, the result is 0 because our Arduino starts and then immediately sends the content of millis, which is 0 at this point. Well, let's do something else. Let's add a delay of 5000 milliseconds. The result is 4999. So pretty good. As you can see, these are the milliseconds since Arduino started. So how it works is Arduino starts up a timer in the background. So timer 0 is just incrementing a number in the background without us doing anything. And by calling the function millis, we actually take a look at this value. And we ask Arduino, please give us this value. And then we get back the milliseconds since Arduino started. And the nice thing is we can use it to write non-blocking code because delay blocks everything. You can't do anything while delay runs, except for interrupts. But if we get rid of delay and use millis instead, we can do so much more. Now let me show you what I mean. I will use millis to blink the onboard LED of my Arduino. So the first thing is pin mode 13, which is the onboard LED. I want it to be an output. And I will also create a variable called stored timestamp equals 0, unsigned long. And then inside of my loop, I check if millis is bigger than stored timestamp plus, let's say, 1000. So it checks constantly if millis is bigger than 0 plus 1000. So 1000. After 1 second, this becomes true and we jump into these curly braces. And then what I want is stored timestamp needs to be updated to the latest value of millis, because now a stored timestamp will increase and we will wait for the next second, right? And while we are here, I would like to toggle the LED. So I would like to digital write pin 13. And now the question is, should I turn it on or should I turn it off? Is it too much to ask for both? Now, if it is on, I would like to turn it off. And if it is off, I would like to turn it on. So what I really need here is digital read 13. We're almost there. So I'm assigning pin 13 to its current state, but that doesn't quite do it, because if it's high, it stays high, and if it's low, it stays low. What I need is to invert it. So I need to invert this digital read right here. In order to invert it, I will add the exclamation mark. So if it is high, then it will be low, and if it's low, then it will be high. Let's see if it works. And as you can see, the LED is blinking and we don't have a delay. So we can do something else inside of our loop that is not blocked. One thing that you might be worried about is this millis function returns the milliseconds, and it increases and increases and increases and increases, and after around 50 days it reaches its maximum. And if the timer tries to increment it above its maximum, it will jump down to 0. So it could happen that inside of stored timestamp there is a very big number, and inside of millis there is 0, and then we check if 0 is bigger than this huge stored number. Wouldn't it take 50 days until it reaches this point again? Actually no, because millis experiences this overflow, but so does this calculation right here. So we have stored timestamp plus 1000 also creates this overflow. So the result right here will also be a tiny number that is slightly bigger than millis in the beginning. So here comes your exercise. I would like to have 2 LEDs blinking. One LED blinking with a speed of 300 milliseconds and another LED with the speed of 400 milliseconds. So I will connect my 2 LEDs, let's say to pin 2 and pin 3. So I now have pin 2 as output, pin 3 as output, and I need to store timestamp of my red LED, and this will be output 2 with 300 milliseconds blinking, and then I need a second variable called stored timestamp green, and this one will wait for 400 milliseconds. And I also need to change digital write and digital read to pin 3 in this case. Let's see how this looks. And as you can see, every LED is blinking at a different pace. If this video was helpful, please like and subscribe to this channel if you're ready to dive deep into the world of Arduino. Leave a comment down below if you have any questions or a different solution to this exercise. Thank you for watching. See you in the next lesson.